looking at transformers, including step-up and step-down transformers. Transformers use the principle of induction to allow voltages to be either increased or decreased when used in circuits. So a transformer consists of two coils, being called primary and secondary. The primary coil is the input coil, and the secondary coil is the output coil. The primary and secondary coils consist of a different number of turns when they're wrapped around a magnetic core, which increases the strength of the magnetic field. A potential difference also exists in the two coils, and a relationship exists between the voltage and the number of turns in the coils on both sides as given below. I'll go through more on this derivation a bit later. A varying current in a coil produces a varying magnetic field or magnetic flux. This magnetic flux can induce a current in another nearby coil. Using this principle, electrical energy can be transferred from one coil to another. Now these two coils can exist next to each other, however it is a lot more efficient to wrap the coils around a magnetic core which provides a low reluctance path. So this magnifies and focuses the magnetic field. Now in that primary winding, the varying current produces that varying magnetic field or that magnetic flux. Now due to the core, the magnetic flux will be the same in the secondary winding, meaning it is the same in both. As the magnetic flux through one turn of the coil is the same on both sides, the voltage per turn is the same on both sides, which is given in this equation here. Now rearranging the equation, what we can find is the relationship between the voltage input and output, as well as the number of turns. Now there are two types of transformers we will consider, being the step-up and the step-down transformers. The step-up transformer turns a smaller voltage into a larger voltage. So you can see in the diagram, the number of primary turns is a lot less than the number of secondary turns of coil. Although the voltage increases, the output current decreases. In a step-down transformer, the output voltage is less than the input voltage. This is due to the fact that the number of secondary turns is lower than the number of primary turns. The output current is also higher than the input current. So transformers are important in the transmission of electricity, and you can see in the diagram at the bottom, when electricity is produced in a large power plant, it can be of a high voltage. However, for efficiency, it is better to transmit electricity at a very high voltage over long distances. When it reaches our house, however, those high voltages are dangerous, so they step down to a usable voltage. Find an online search engine, find the mains power voltage and frequency used in your city.